So, if you're building RAG systems for production, you know the drill. Your vector search keeps pulling up the wrong chunks, your agent starts hallucinating with his weird confidence, and yep, there you are, debugging embeddings at 2 in the morning. It's a pain we've all felt.
But here's a crazy thought. What if the problem isn't just your code? What if the whole idea, the entire embedding pipeline, is actually the wrong tool for the job when precision really matters? Today, we're going to dive deep into something called vectorless RAG. That's right, no vector databases, no chunking, no embeddings. It's a completely different way of thinking about retrieval, and it might just change how you build these systems.
I mean, every single developer hits this wall. The vector search finds chunks that sound similar but are factually useless. Then the agent takes that garbage context and just makes stuff up. And that leaves you staring into this mathematical soup of high-dimensional vectors, trying to figure out where it all went off the rails.
Okay, so before we can really appreciate the solution, we have to get brutally honest about why the traditional vector pipeline is so, well, brittle. It really boils down to 3 major flaws that are baked right into the architecture.
First up, chunking is a context killer. Think about it. We take this beautifully structured 50-page financial report, with tables and footnotes and appendices, and we just chop it up into these random 512 token pieces. It's like you're paying this structural integrity tax, where a super important table is suddenly separated from the one paragraph that actually explains what it means. All that document hierarchy, gone.
Second, and this is the big one, similarity is not the same thing as relevance. Vector search is basically a search for a linguistic vibe. So when you ask for Q3 2024 revenue, it finds stuff about Q2 revenue and Q4 revenue because, hey, the words sound similar. But for a financial analyst, that answer isn't just a little off, it's 100% wrong. Searching by vibe just doesn't cut it.
And finally, this one is a real killer. Cross-references are totally invisible to vector search. A document can literally tell you where to look, saying, for more details, see Appendix G. But the vector for that sentence has absolutely nothing in common, mathematically, with the vectors for the content in Appendix G. So your RAG system is just blind to these pointers and silently fails.
So if brute force similarity search is the problem, what's the answer? Well, it takes a total pivot in how we think about this. We have to move away from just searching for stuff and start thinking about structured reasoning.
This slide just nails the difference. Traditional vector RAG is asking a math question. What text looks similar to my query? But this new approach with frameworks like PageIndex totally flips it. It asks a much more human question. Where would an expert actually navigate in this document to find the answer? It's a huge shift from pure math to actual logic.
And this is that idea in practice. PageIndex. It's an open-source, vectorless RAG framework. The whole idea is to turn a document into this hierarchical, tree-structured index. This lets a large language model reason its way through the document structure to find what it needs, completely sidestepping the need for a vector database.
Okay, so how does this thing actually work under the hood? It's a 3-stage pipeline that completely replaces that old chunk embed search model we're used to. Let's walk through it.
First is tree generation. The system reads the whole document and spits out a JSON index that kind of mirrors its structure. Think of it like a super smart table of contents. Then comes the really cool part. Reasoning-based retrieval. An LLM gets the user's query and this lightweight tree, just titles and summaries, so it's super cheap on tokens. The LLM then thinks through the structure to pick the best nodes. And finally, the targeted fetch. Only the raw text from those specific nodes is grabbed and sent to another LLM call to get the final answer. And here's what that tree actually looks like. It's not scary, it's just JSON. Every section becomes a node with an ID, a title, a little summary, and any subsections nested inside. This is the map the LLM uses to navigate the document's logic, not just its linguistic vibe. It directly solves that problem we talked about earlier.
Now, this all sounds fantastic in theory, right? But what about the real world? How does it actually perform? Well, the results are kind of shocking, but they do come with a pretty big trade-off. This is where we get into the tough engineering decisions you have to make.
So get this. On Finance Bench, which is like the gold standard test for financial Q&A, traditional vector RAG systems kind of struggle. They hover around 65% accuracy. A system using PageIndex, on the other hand, it hits a staggering 98.7%. I mean, that's not just a little bit better, that's a whole different league.
Yeah, just let that number sink in for a second. 98.7%.
In fields where being factually correct is everything, we're talking finance, law, medicine, this is the kind of reliability that takes a project from a cool demo to a tool you can actually bet your business on. But, and this is a huge but, you always have to be a little skeptical of shiny benchmark scores. As this quote points out, amazing numbers often hide the real-world costs, like latency or cost per query. That incredible accuracy, it comes at a price.
And this is the price: latency. A vector search is blazing fast, we're talking milliseconds. But reasoning-based retrieval needs to make multiple LLM calls just to navigate the tree. So as you can see, that retrieval stage balloons from under a second to maybe 30 seconds or even more. The answer is way, way more accurate, but it's also much, much slower.
So what does this all mean? It means vectorless RAG isn't a silver bullet. It's not a universal replacement for vector search. It's a new, really powerful tool in our toolbox. And the secret is knowing which tool to use for which job.
This chart basically lays it all out. It's your cheat sheet. Stick with classic vector RAI when you need speed and scale over tons of unstructured documents. A hybrid approach is great when you need a balance of semantic and keyword search. But for those structured documents, legal contracts, financial filings, technical manuals, where accuracy and being able to trace the answer are non-negotiable, a vectorless approach is the clear winner.
So, what's the big takeaway here? The whole chunk and embed pipeline was never the only way to build RAG. It was just the first way that really worked at scale. And what we're learning now is that for the most important documents inside a company, having a system that can reason over structure is always going to beat a system that's just guessing based on similarity.
And that leaves us with one final question to take back to your own work. Take a hard look at your pipeline and ask yourself, is it just searching for things that sound similar, or are you actually letting it reason its way to the correct answer? Because that small difference might just be everything.